are worth knowing because he's a very humble person that if you saw him walking down the street, you would never know he had all this behind him and in front of him. But he is a futurist, researcher, and author who investigates the innovative application and strategic implications of science and technology on society and business. He is the author of Disruptive, Rewriting the Rules of Physics, which is a thought-provoking book that introduces modern mechanics, a unified model of motion that is not only more accurate than Einstein's theory of relativity, but will fundamentally change how we view modern physics. Steve is a subject matter leader in the relativity community of the National Philosophy Alliance. He has published several papers on relativity theory and has spoken at American Association for the Advancement of Science and NPA conferences at universities across the United States. Steve began his career in technology, joining Science Applications International Corporation's software engineering team after completing a BS in computer science and psychology. After completing his MBA, Steve joined Accenture, where he was able to pursue mastery in two areas, technology and business. Steve remained in consulting until joining Wells Fargo, where he is Senior Vice President responsible for the delivery of large strategic initiatives. A lifelong learner, Steve is a computer science graduate student at the Georgia Institute of Technology, where he is specializing in artificial interactive intelligence and machine learning. Please help me welcome Steve Bryant.
Thanks, Steph.
How is it
But well-deserved accolades.
Thank you. Definitely appreciate that. Why don't we take just a couple minutes break so that we can get the panelists to come on up. We can get everyone mic'd, and then we'll come back together. So let's plan on maybe just a brief 5-minute break or so, and I'll just get back on the microphone when we're ready to reconvene. But if I can invite the panelists to come on up and start getting people mic'd.
Check. Microphone check, 1, 2. Brand new, coming through. You know how we do?
That's all you.
Is trying to.
Okay, hey, welcome back. We're live once again here at Studio City, Wells Fargo. If we can invite people to come back to their seats, we'll go ahead and get started. I think, first off, I want to thank Wells Fargo for hosting us in this really nice space. I think this is probably the third or fourth event that we've held here, and it's always been really nice, and the team that's helped us out with audio visuals or catering, et cetera, has been top notch. So I just want to, if you can help me acknowledge our team with a round of applause, I really appreciate it. For those, just logistics, actually there's a big sign there, so maybe I don't need to say logistics. If anyone does need the restroom, they are upstairs. So just FYI on that. And I think what we'll do is we'll go ahead and get started. So Deb, once again, thank you for introducing me and a little bit about my background. I've had a lifelong passion about artificial intelligence, and am really excited to be involved in it now, both professionally and academically. So it's kind of a fun part of my life to really be doing something that I love to do. And about, I don't know, I want to call it about 6 months ago, Deb and I started to talk about, hey, let's pull together a discussion with the membership of the National Black PA Association. And not only was Deb very supportive, she said, and I have someone I want you to meet. And that's when she introduced me to Keita, who also had a very similar idea. And we were able to come together working with Deb, and what you hear tonight is the first part of what I'll call the beginning of an AI journey. And you'll hear a little bit more about that tonight. Our topic today is going to be artificial intelligence. My role as moderator, I'm going to try and keep us fun and light, but really we're here to hear our panelists tonight. So I'll have some interesting questions that I hope are thought-provoking, and I hope that we, as a result, really get a really engaging conversation. At the end of our time together, I think we'll have until about 8 or so. But at the end of our time together, I will open it up for people in the audience if you have questions you'd like to ask the panelists. To more than happy to entertain your questions. And speaking on behalf of the panelists, I think more than excited to answer your questions. So without further ado, we're going to go ahead and get started. The way we're going to do that is I'm just going to ask each of the panelists to briefly introduce yourself, and in doing so, just share a little bit about what your role is in AI, or how it's playing a role in what you do, whether it's your own company or a company you work for. So if you could just describe a little bit about yourself, and we'll start with Keita.
Great. Hi, I'm Keita Broadwater. I run a company called Oxygen AI. We have 2 lines of business. One is to do consulting with a large machine learning and data science component. And the other is to build products. And the products that we're building also have a large machine learning features and components to them. So, thank you.
Hi everybody, my name is Ayori Selassie. So I work at Salesforce, the tower right down the street. I run product marketing for Salesforce Einstein, which is their AI platform. I also run AI strategy, AI partner strategy. So if you're an entrepreneur or partner out there and you're looking to partner with Salesforce and embedding our AI technologies in that, I run that whole experience. But I'm also an entrepreneur on the side. So I'm the founder and CEO of Selfpreneur. And we're really excited about some of the things that we're working on right now. You'll probably see a little handout running around from our new brand that we're launching, AI Newbies. And the mission around AI Newbies is essentially to educate and enable non-technical leaders on how to leverage the power of artificial intelligence and move it from the experimentation phase, which most people are currently stuck at, to the actual real production, successful business result stage.
Hi everyone, my name is Emmanuel. I currently work at Google. I manage our portfolio of on-device and privacy-preserving artificial intelligence that goes into all the different Google phones, so both Android and the Pixel platform. I'm also on the US delegation for artificial intelligence standards and also represent Google at the international level as well.
Hello,
My name is Will Ford. I've been in the machine learning space since 2003-ish. I did my PhD at Caltech. I left, went into consulting and startups. Most recently, I was at a company called Chegg in the ed tech space. Currently, I'm independent, but I've been around this space for a very long time. I've worked in business, consulting, and then the startups. We would go into enterprise and help them convert. So I've been exposed to quite a few different companies, and I've seen very different approaches to leveraging AI and predictive analytics in general.
Very cool, thank you. And sitting in front of us here is just a wealth of experience and knowledge, both practical, academic, just a wide range. And I'm looking forward to the questions that we have and the answers that you all give this evening. So let's start with just a little bit about the history of artificial intelligence. So if we think about the media today, right? You can't turn on your TV without something, some commercial or some show portraying artificial intelligence. And if you just like landed here from outer space, I have to leave that in for space and physics. But anyway, if you just landed here from outer space, you might think AI is kind of a new revolution. But in reality, artificial intelligence, the phrase was coined in the 50s. The first AI program was written in the 50s. If you look at the foundation of the AI that's out there today, machine learning, deep learning, et cetera, the first foundational frameworks of it was also laid in the 50s. So can you help us understand what is AI? Why is it so prevalent today? What makes it so popular today versus the prior 40 or 50 or 60 years? Well, you have the microphone, so why don't we go ahead and start with you?
Yeah, so I take a very high-level view of AI. I think of it as advanced algorithms to solve problems. I think it's so prevalent today in the same way that web pages became very prevalent, let's say 10 years ago. Access. You can do the types of computations on your notebook computer that were impossible a decade ago on the most standard computers. Let's say that it's quite a bit of it.
In addition to the compute power, which has changed, I think you also have a massive amount of data that is now collected because you cannot not interact with the computer during the course of your day. Right? And so all of that data being amassed in different places gives you interesting opportunities to be able to leverage that to create new insights that previously just weren't possible. And so I think that's an additional component as well.
Yeah, so one thing that I like to do is when we talk about artificial intelligence, I like to I hate the word artificial intelligence, to just be blunt. I prefer the term collective intelligence because it's actually more specific. It helps you understand better what it really is. Collections of data being pushed into algorithms to present you with a result, essentially oftentimes a prediction or some sort of insight about that data. And the funny thing about the word collective intelligence, you talk about the 50s. I get too excited, I'm going to really keep this short. But yeah, in the 50s, that was when the internet was really being built, and the internet was built to support a collective intelligence. And we're finally now getting to that point where we're actually able to leverage it, leverage the internet and leverage all of that data that's been generated because of what you guys mentioned, the compute power. And it's funny, I started my career 20 years ago during the dot-com boom. I founded the first black-owned technology store in Oakland with my brother. And during that time, I ended up working with a company called Schneider Electric. And we supported utilities across the country. Someone in here mentioned utilities. And utilities is one of the industries that has been collecting massive and massive amounts of data since forever. So if you think about the meters on your house, there are actually multiple meters within every building collecting data every 5 seconds. and pushing it to some system. And this has been happening forever. Same thing with telecommunications and all these other industries, air traffic control. And when the iPod was getting launched, I was actually building some of the first predictive algorithms that leverage utilities data to help make predictions to protect the grid here in California when we were going through those grid collapses and having rolling blackouts. So we were using data back then to be able to predict when a blackout, when rolling blackouts would occur because the grid would be affected. But just to tell a little bit of a story, like that was so painful because we had so much data and it took days sometimes to calculate and recalculate those algorithms. Today, you can do that same thing on a smartphone, like locally, with a database in the cloud on Amazon. And someone's in here from Amazon as well. So basically, we've got this perfect storm where now we have all this technology that's allowing us to do what we've always wanted to do far more effectively.
Those are great explanations. I don't have too much to add to them. I would just say that all of these factors that they mentioned have come together very recently in some cases for some applications, and it's just been amazing that they work so well. One example I will give is that you have something called object detection, where you can have a machine take an image or take a video and recognize different elements in that picture or video, be able to identify them. There's another technology called captioning, where it can take a picture, an algorithm can take a picture and generate a caption underneath it. So there's a picture of two boys playing baseball in the field, it'll say, 2 boys playing baseball in the field. So the algorithms existed, a lot of the data, you know, we've all had pictures all of our lives, right? So the data in some form or another existed, but a lot of the elements are just now coming together and being designed together in such a way that we can have these great advances that allow things like captioning, self-driving cars, and other applications that work so very well that they can be applied and turned into businesses.
So I think one of the other confusing things about artificial intelligence is how it's defined and people's perception of what it actually does. So I spent probably 16 hours in Dublin in meetings trying to talk to other nations, delegations about how to define AI. We didn't come to a consensus. But what's interesting is that, you know, oftentimes when you think about it, you think of this image of a robot, or you think of Terminator, you think of these very distant images that we've had because of movies and Hollywood, etc. But, you know, as you mentioned earlier about being able to recognize this is a boy, this is a ball, this is a dog, this is a cat. Today, the majority of artificial intelligence or machine learning is based off of, it's called supervised learning, meaning that people are actually labeling what those things are. So there's this kind of perception that these systems just walk around, or you just turn one of these machine learning systems on and then they just recognize all the stuff, all the things in the photos, right? It's the same reason why if you have Facebook, you can start tagging who the people are before it will start to tag things for you, because you have to train it so that it understands what those types of parameters are. And so I just wanted to make sure, like, just to add that kind of clarifying component, because I do think sometimes we, and I think the media portrays it often as this, we are in this space where now robots are going to be taking over everything. And we are, I'm still waiting for a washing machine that doesn't shrink my clothes. So we're quite a ways away from that.
So let's stay there for just a moment. Because you raised a good point, right? If you look at the media and you watch popular movies, whether it's Terminator or the Cylons from Battlestar Galactica or the robots in Westworld, right? You see this whole intelligent, human-like robotics that are eventually, whether they're benevolent or not, they end up destroying mankind. But yet at the same time, I think that there are two terms that I've seen out there. One is AGI for artificial general intelligence, which seems to have a longer horizon, but also is what is kind of portrayed in these shows, versus artificial intelligence, which encompasses things like supervised learning that you've talked about. Where do you see, how do you help people understand the difference between the two to help separate kind of what's real versus what's hyped?
Well, I guess the first thing is that I think there's actually a responsibility that companies have to have on how they're marketing their products, which I think is that's not a cop-out for my answer though. But I do think to some degree that the idea of artificial general intelligence, meaning there's a system that you can implement that will adapt to whatever the scenario is without you having to specifically train it on that thing. And so when I think of artificial intelligence, the definition for me is being able to, as having a system that can learn and process and execute functions at a level similar to human cognition. That is where I draw the personal line between just a smart machine and like artificial intelligence. And I think the more cognitive, and if you use that as a frame of reference, the more cognitive-like functions the system can do, the closer you get to what I consider artificial general intelligence. Meaning that you have a system that can learn in many different scenarios off many different types of data, and then apply them in a way that would allow it to successfully execute a function. And so that's how I would consider artificial, that's how I perceive the difference between where we are today and where technology will be in the future.
Just kind of on your point, it's kind of hard, I think, for people to understand the difference between this generalized AI and like what AI actually is today, because when we hear the word artificial intelligence, we think that there is something else controlling it. But today, when we hear the word AI, we're literally saying this is something that a human made, right? So with AI newbies, we use the key benefit statement, learn to control machines. Every time you're interacting with some form of AI, it is something that someone has already controlled. Like they have told it to do a specific task. So as you're going out and trying to figure out how am I going to leverage AI, you are going to tell it exactly what you want it to do. The other thing that I think is really what makes general AI so far away, so complicated, so difficult, to the point of it being ultimately unrealistic today, is that AI is still reliant upon data. And I mean, who here manages databases today? Like, literally just getting an answer from the data that you have today is still so hard. So that's why we're now starting to use AI just to do that. And in order for you to create a generalized AI, you're going to have some sort of standardizations around your metadata that connects all of these different data systems together so that they can understand, so that every different data system has some sort of commonality, common thread, so that the AI can actually make these connections and then build its own algorithms. That's just really hard. And like, nobody wants to do that. Why? Because the only people who would benefit from it today is like governments. So yeah, maybe some of it exists somewhere today. But in general, this is not something that is going to be beneficial enough to give reason to pay for the cost to actually make it quality and effective.
I have a really simple way of explaining it. AI today, most models solve one problem. When you talk about generalized AI systems, it would be a system that adapts and solves innumerable problems, right? So feeding off of making sure that you have all the data in place, you also focus that model on solving just one thing.
Keita, do you have anything you wanted to add to that?
Oh, no.
Okay. So now that we have an understanding of kind of what AI is, We've begun to separate a little bit of the hype from what it can and can't do. Let's talk about what it can do. So let's talk about some of the benefits, right? I think if you go back and you think of different systems that you see in the media, or things that many of us may have used throughout our lives, I think back to something simple, right? A spam filter. If you go back into the Wayback Machine, many of us had to always set up those spam filters and put in different rules and try and always train it on this is spam, this isn't spam, and set up a new rule. And there was always a spam that came in that busted past the filter. Today, a lot of these companies have put AI components in front of our email, and it's learning all the time, and it's detecting and trapping or labeling spam for us. That's one application that we're seeing is a benefit. If you watch the media, there's all sorts of benefits that are coming out for medical research and applications. We're hearing all sorts of things about self-driving cars, which, depending on where you're at on that, if you're Tesla, maybe you're closer to implementation than if you're some of the other companies that are out there. But nonetheless, you're seeing a lot of progress in that. So help us understand, what are some of the applications you guys are seeing, and tell us the gamut to give us a broad understanding of how AI is being used in various different applications.
I'll just start at a high level and just mention one of my clients' problems that I were able to solve. So at a high level, when I talk about applications of machine learning, I talk about 3 areas. One is using what some people call tabular data. It's like data that you would see in an Excel file. Data structured in rows and columns. Another is in visual data. So I talked about earlier, video, pictures, working with that type of data. Another type of data is text data, natural language, basically. So not just text, but also spoken language. So those are the 3 major mediums that a lot of applications are being developed in. With my clients, mostly I work with tabular data, the Excel data. So I may work with a nonprofit, for instance. We've dealt with nonprofits that have a lot of data related to their constituents. And they have missions. They want to increase the social good around their mission. And they want to see how their past results can be improved. So we're able to take that data from those nonprofits and give them some suggestions, and give them some predictions about what could happen, what would happen if they tried one tactic or another tactic, or one strategy or another strategy. So one solid example is one nonprofit wanted to figure out, they had regional operations teams, so maybe a team of 3 in the DC area, but they had maybe 10,000 constituents in that area. So they want to figure out, who should we be cold calling? There's only so many resources we have. Who should we call? Who should we invite to our events? And we were able to come up with a model that predicted, out of your pool of 10,000, here are the people you should be focusing on. And it worked quite well. They were quite surprised. They said, how did you know that this person will be eager to come to the event? Because you cold call people, sometimes they hang up, sometimes they're eager. So we were able to help them cherry pick the people who will be eager to come to their events. So it's just one application.
So I really focus on the space of business. Ultimately, every business has a set of core functions that they need to be able to do. They need to be able to sell more, faster. They need to be able to find their customers more effectively, market so that they can market to them. They need to be able to support the customers that they currently have so that they can retain them. So, and then there's other functions in finance and HR, and how do you get the employees, and how do you make sure the money's right? So all of those different functions in a business is going to have some sort of process that is data-driven. In the sales process, your data-driven process is lead conversion. That's the first one. Then it is deal closure. So ultimately, if you want to use AI to predict something, you want to predict which one of these leads are going to close. That's an example, an abstract example of what Keita just explained. But then once I know that I can get this customer to show up and I can talk to this customer, now I have from 1,000 customers who were leads. Now I have 100 customers who are opportunities. Now I want to know which one of these deals are more likely to close that's going to result in money and revenue for my business. That's another prediction. Unfortunately, when these things are data-driven and very tightly connected to processes in the company, it's far easier to build a quality prediction. And so ultimately, any process in your business that has data behind it, with very clear indicators of what you're looking for, lead open or closed, deal open or closed, project late or on time, those are things that you can easily build predictions for. And then when you look into customer service, like you talked about text, for example, every time you log a case, hey, here's my issue. Some person needs to read that case and decipher what category it lives in. But now that we have AI can actually do that for us. It can read it and say, this belongs in this category. And then you can have other processes that automatically route that case to the effective team. So these are things that essentially allow you to reduce the amount of time that humans would normally spend on things, because you have these better quality predictions that are generated by that AI.
I'll just mention just a couple. So I mainly deal with consumer-facing products, right? So I think ranking and recommendation systems are things that we engage with almost on a daily basis, if not everyone on a daily basis. And so these are two areas that, obviously, and I work at Google, so ranking is a huge thing for us. But it's perfectly optimized. Ranking systems are perfectly optimized for machine learning. I think there are some other interesting use cases that allow experiences to, I would almost say, that enable really magical experiences. And so I'm not sure, has anyone heard of Call Screen? It was like a recent feature launched in the Pixel phones this past year. Well, essentially, it was a really interesting exercise in creating a product that does not necessarily require connection to a server to run actual intelligence. And it was built in directly into the phone, and it did actual live transcription of the actual speech. So if someone calls you, you would actually have the service run, and you would actually literally be able to read line by line as the person's speaking what the person's saying. And then it actually, layered on top of that, it starts to understand intent and start to understand if it's something that you should try to pick up, should you tell them to call back, like what are the recommended things for you to be able to do. These actually live directly on the device. It's not connected to Google server. If you turned